positive 4y minus 29. Then we want to complete the square. So square that. We'll put the c here. It is 9. If we add 9 to the y minus 20. We still are not in standard form, so we need to complete, Gray's common factor. X squared equals, take out the 4. You're left with y minus 5. All right, is standard form. So we can go about solving for these things. So the vertex first will be 3, 5. Now, the p-value is this value we know is equal to 4p. So we set that equal. 4p equals 4, and we solve for p. Divide by 4, p equals 1. There we go. Now let's start graphing this before we worry about the focus. It's best to tell from the graph. So the vertex is 3, 5. There we go. That's a vertex. We know that x squared, this is, p is positive, so it is, and it's x squared, so it's opening up. So p is 1, so the focus is going to be inside the parabola, it's going to be up 1. That will be the focus, so the focus will be 3, 6. What does that do for the directrix? Well, the directrix is then going to be the line y equals 4, because it's p distance away from the vertex. So y equals 4. We decided already that it opens up. But we don't know how wide it is unless we plot the lattice rectum. So we know that the lattice rectum is 4. Lattice rectum is equal to 4p, which is equal to this quantity right here, is equal to 4. So we go to the focus, and we split the lattice rectum. Half will go to the right, and we'll go 1, 2, so this will be at 5. Half will go to the left, 1, 2. So we're going to be over here at 1. So there's how wide our parabola is. So we graph the parabola, going from the vertex, there we go. And so just to say again, the lattice rectum is 4. The distance from here to here is 4 units. That's how I knew how wide it was. Okay, let's do the next one. So we're going to do we're going to keep the squared term on the left, y squared minus 4y. Those go on the left, everything else to the right. So that's going to be 12x will move over and be negative 12x. 56 will move over, we will add 56. Now, the next thing to do is complete the square. Y. And then we'll add b2, which will be negative 2 squared. Our c value will be this squared plus 4. We'll add 4 to the right side to keep it balanced. So then we have negative 12x, add those two together to get plus 60. To get into standard form, we're going to nothing to the left. Take out a greatest common factor. We take out negative 12. What's left? X, 60 divided by negative 12 is negative 5. Now we're ready to identify characteristics of the parabola. The vertex is 5, 2, 5, 2. Let's graph that. X is 5, y is 2. There's the focus. Well, let's find the p-value. This value right here is 4p. 4p equals negative 12. P will be equal to negative 3. P will be equal to negative 3. It's y squared, so it's going left or right. It is negative, so it's going left. Now I know what to do with that p-value. I go to my vertex and I go left 3. 1, 2, 3. So here I have a focus, and that focus is at 2, 2. If the focus is to the left, then the directrix is to the right 3 units. So we go 6, 7, 8. And our directrix will be the straight line, vertical line, x equals 8. X equals 8. We already said we know this opens left. Now we need the lattice rectum to tell us how wide it is. So we know that the lattice rectum is 12. So we go to the focus. We go up 6 units. 2 plus 6 is 8. 2 minus 6, negative 4. And that's how wide. So there we have the lattice rectum, 12 units. And we knew it was going to be 12 units. Now we're ready to draw the graph, the parabola. Okay, there you go. Okay, various ways we can get this problem. Zoom in just a tad. I can't. Okay, 2, 5, focus at 4, 5. I like to sketch. So x is 2, 5. There's a vertex. The focus is at 5. I'll put that in a different color. That tells me a lot. That tells me that p equals, that tells me that we're going right, and therefore p is positive 2, because we're going to. The focus is always inside the curve. All right, but I still don't need anything else because I have h and k. I'm ready to write my equation. It's going to the right, so it's y squared. So it's y minus k squared equals 4 times p times x minus h. H is 2, x minus 2. So we'll write that time, y minus 5 squared equals 8 times x minus 2. And that would be the standard form of that one. Okay, so here we're given different things. We're given a graph opens down. Okay, that tells me x squared, p is less than 0. A vertex 4, negative 2. Let's sketch that, just a little tiny sketch. X is 4, negative 2. We have a vertex here, we know down. The lattice rectum has a length of 40. So it's going to be going down, and it's a very wide parabola. So let's just get the idea going here, right? It's a very wide parabola. I have h and k, all I need is p, and I have a way to p. We know that the lattice rectum is 4p. We're going to set that equal to the length of the lattice rectum, 40, we get a p equals 10. It tells me is down here at negative 12, I have the focus. Because it's 10 units, there it is, p is 10 to the focus. Okay, that was the vertex up here. Now I'm ready to write my equation. So it's x squared because it's going up or down, and so it's h squared equals 4 times p, which is, one thing, negative 10. Because this is going down, p must be negative. So it's 4 times negative 10 times y minus k. Minus k, which is plus 2. Let's write that one more time. We have x minus 4 squared equals negative 40 times y plus 2. And that is the standard form of our parabola. Third problem, how do we do this? Let's read it. Solar panels follow a parabolic shape with a boiler always located at the focus. One particular solar panel has a 50 and a depth of 12. That is not talking about vertices or focus or right now. It's just telling us about a solar panel. Where should the boiler, which will be the focus of this solar panel, be located? So it's asked, where is the focus? So let's draw. First of all, draw yourself a coordinate plane, and we're going to put this solar panel with a vertex at 0, 0. We can put it anywhere we want, right? So let's draw. This parabola is really wide. I'm going to draw it here really wide. But it's about, I'm going to draw it even shorter. So it's a 12 high. Okay, so we know that this distance up here is 12. We know that this distance is 50. So there's 25 units to the 25 units to the left, because it said that the width of the solar panel is 50. Okay, so we know that the depth of the solar panel looks like it's 12 feet. Where should the boiler be located? I have no idea where the boiler should be located. They have not told me that. They've only told me two things: height, width. Okay, but let's see what else I can discern. First of all, I know the vertex. The vertex is 0, 0, and for me, that's HK. For us, that's HK. The other thing, which is new to us with word problems, is they've told us about at least one point on the parabola. This point is an x value, and we know what it is, right? It is, x is 25 over 25 with a height of 12, a point. We're going to use this as substitution to find out something. Let's see what we need to find out. So we know this is an upward parameter. So x minus h squared equals 4p times y minus k. All right, let's vertex. X minus 0 squared equals 4p times y minus 0. Okay. Do I know anything else? I do. I know x and I know y. Excuse me, yeah, I said this is 4y, but it's p. Okay, this is 4p. I don't know p, but I do know x and y. So let's substitute x and y, the x and y that we have. X is 25. minus 0 squared equals 4p times y 12 minus 0. It's not squared. Okay? So this is just be 12. This will be 25 squared. 25 squared is 625. Equals 4p times 12. 625 equals 48p. And when I divide, I'm trying to find p. I divide by 48, I get 13.02. P equals 13.02. So what that tells me is that my boiler is going to be located right here, slightly above the height of the solar panel. Okay? So that is the focus, and it is 0, we'll just call it 013. Okay? And there's my focus. So that's the question. Where should the boiler of the solar panel be located? 13 feet above the ground. Okay, that's where it should be. That's the answer to my question. So when you have word problems, here's what usually you do. Usually you'll put the parabola, whether it's going left and right or up and down, with the vertex at 0, 0. You know you have all these. You will either get an x and a y and find p, or you will get an x and a p and you'll have to find y. So this question can be asked many ways. You know h and k because you put it at the vertex. Okay, so because you put it where you want it. But the two variables you have to solve for the missing one. Okay, so give your homework, best try, and I will see you in class on Thursday.